There are three things we need to know about the motor for VFD. Number one, it should be three-phase motor. Second, the parameters to be entered in VFD. And last, motor assessment. VFDs are designed for three-phase motor. So single-phase motor cannot be driven with VFD. We need to know the parameters of the motor. It is very important. Parameters like power, voltage, current, frequency, motor poles, rated speed, motor slip. We need to enter motor parameters in VFD, which will help VFD to protect the motor and change the characteristic of VFD as required for the motor. Here I am sharing a motor's nameplate. It might seem complicated, but we will go through the parameters which we require. Here we will locate the required parameters. So here we have kilowatt, which is mentioned 8.8, and the speed, which is mentioned 1750, the rated voltage of the motor, rated frequency of the motor, and the rated current. And we need to know motor poles and rated slip. Here is another example of motor nameplate. All relevant informations are marked. We might see on the motor's plate like two values of voltage and two values of current. Well, that is related to the voltage at star and delta wire configuration. For example, here at delta connection, the voltage will be 380, and at star connection, the voltage will be 660. And at 380 voltage, the amperes will be 68.8 amps, and at 660 volt the current will be 39.6. We are familiar with parameters like voltage, power, current and speed. But rated slip. What is the concept of rated slip? It is the difference between rated speed and calculated or theoretical speed. Here I am sharing the formula to calculate rated slip. For example, we have a motor rated 60 Hz and 1740 rpm as speed, and the motor is 4 poles. Then calculated rated slip will be 2 Hz. The motor should be running at 60 Hz, but actually mechanical speed will be at 58 Hz. The rated speed is the mechanical speed. In case we have a motor with greater slip, for example slip higher than 100 rpm, the chances are that at lower frequency much higher torque will be required. The motor poles can be 2, 4 or 6. It can be any even number. It can be 20 poles for example. Just very briefly, the motor poles have an effect on two things of motor design. It affects on torque and speed. More poles, the lesser the speed and the higher will be the torque. And if the poles are less, more will be the speed and reduced torque. Normally 4 poles motor is the most common for any application other than fan and pump. For fan and pump, 2 pole motors are common. With the help of rated frequency and motor speed, we can calculate the motor poles easily. I have shared a table here for an overview. Lastly, the motor assessment. We need to know if the motor is an induction motor or a permanent magnet motor. For a permanent magnet motor, the VFD should have the capability. And second, the motor type. Nowadays, the majority of motors are suitable for VFD. We can encounter an old motor which might not be suitable for VFD, or a motor that is rewinded and might not be suitable for VFD. Generally, the motor insulation should be rated at least at 1000 volt. The recommended is 1600 volt. If the insulation is not meant for the VFD, the direct effect will be the motor body